Okay, all right. So what we need to discuss here, show that the function defined by f of x equal to 1 by x is 1, 1 and 1, 2, where R here star is the set of non-zero real numbers. Non-zero real numbers. Okay. Is the result true? If the domain R is replaced by N with codomain being the same as R. So that means if R star is replaced by N natural numbers, then this result is true or not. One and down to is if is one and down to or not is what we need to check. Okay.
Yes, sir.
So you have any idea? Any idea how to?
Sir, I can identify if it's onto or here he gave it, but even otherwise I can identify, but I don't know how to write the proof.
Yeah, you have tried by using the definition. First of all, R star is given like this. This R star is what you know, non-zero real numbers. Real numbers, but not zero. Non-zero real numbers. R star. Okay. Now, f is a function from R star to R star. How it is defined? Defined as f of x equal to 1 by x. 1 and on 2 we need to show. So how do you show 1 1? How do you show 1 1 is? How do you show 1 1 is this like this? See, you take let here why here this R star no 0 is there. Why non-zero real numbers? Because if x is 0, 1 by x will not be defined. No? X is 0, 1 by x is not defined. Therefore, domain is all real numbers but 0. Is that okay?
Yes, sir.
So 1 1. So how do you prove 1 1 like this? Let x1 comma x2 belongs to R star. What is this? Domain. You take any two elements from the domain. How? Such that, how do you take? Such that they are not equal. X1 is not equal to x2. Different elements you take, then what will happen? 1 by x1 is also not equal to 1 by x2. Yes or no? You take any two real numbers which are not equal, then their reciprocals also not equal. Reciprocals, if you bring x2 this side, x1 that side, x1 is there, not equal to x2. x2 you bring this side, x1 you bring that side, still unequal only, na they are. Yes or no?
Yes, sir.
Like that. So 1 by x1 is also not equal. So what you can say f of x1 is not equal to f of x2. So what does it mean? Different real numbers if you take, they have different images. Different elements have different images. So therefore, what you can say? So different elements have different images. Therefore, what is the conclusion of this? 1 1. Okay, this is 1. Or another way is what? Let x1 comma x2 belongs to R star domain. How do you take? Such that you can take like this also, such that f of x, if images are equal, no two elements should have same images. No two elements should have same images. No two distinct elements have same. If images are equal, then what will happen? 1 by x1 is equal to 1 by x2. Let's take like this. Then automatically what will happen? x1 equal to x2. This is true for all real numbers. So whatever real number you take, this is true. This way also you can prove.
Yes,
Hope you
sir.
understand. If you start with
Yes,
f of
sir.
x, so that means if you put not equal here, then here not equal, here not equal. That's the meaning actually. The same thing only. If you put not, see here equal to is there, this equal, reverse.
Yes,
Simple.
sir. Got it.
Either this way you can prove. If you take x1, x2, you have to start with not equal. If you take f of x1, f of x2, then you should start with equals. Okay, you understand?
Yes, sir.
This is how you should prove.
Yes,
Okay.
sir.
Then we'll see on to how we go on. Okay, on to how we see on to also every element in V should have, every element in codomain should have at least one pre-image. Yes or no?
Yes, sir.
Now let's take, let Y belongs to R star. What is this R star? Where we are taking codomain. Yes or no? Codomain is
Yes,
also
sir.
R star here. Codomain. From codomain, if I take Y, how I am taking? Such that, okay, let Y belongs to R star codomain such that there is at least one pre-image. X belongs to pre-image. X belongs to R star. That is domain. In domain there exists one pre-image that we need to check. Okay. What does
Yes,
it
sir.
mean then? You know what? F of X equal to Y. You understand? So pre-image of Y is X means this only, no? Image of X is Y. That means pre-image of Y is X.
Yes, sir.
Like this we are taking.
Yes, sir.
Then we need to find out now pre-image. What is that pre-image? 1 by X equal to Y. So X equal to what? 1 by Y. So what is pre-image? Therefore, what is the pre-image? Pre-image of Y is what? Pre-image of Y is X now. What is X?
X.
1 by Y.
1 by Y. Yes, sir.
Like that, pre-image of Y is 1 by Y. That is also belongs to R star. Yes or no? Is there any real number whose pre-image doesn't exist? Is there any real number pre-image doesn't exist? No.
No, sir.
Because Y if you take, no, 1 by Y is also real number, no? If you take, say, for example, so pre-image Y is 1 by Y that belongs to R, always exists. So therefore,
Yes, sir.
if is onto, simply you can write. See, what does it mean? I am writing here. Just I will write here. Yeah. See, simply you take an example. You take an example. What is it? So this is R star, and this is also R star. We can't write all the elements, but we write. See, for example, if I take here 2, its pre-image is what, 1 by 2. Yes or no?
Yes, sir.
If I take here if I take 1 by 2, its pre-image is 2. Yes or no?
Yes, sir.
Yeah, like that. See, f of X is 1 by X, I know. F of 2 is what? 1 by 2. F of 1
Yes,
by
sir.
2. F of 1 by 2 is 2. So 2 pre-image is 1 by 2. 1 by 2 pre-image is 2. Like that, you take whatever real number you want. Its pre-image will be there. You take here 100, you take. Its pre-image will be there. 1 by 100. Yes or no? Yes or no?
Yes, sir. Yes, sir.
So pre-image is, for every element, pre-image is its reciprocal. So that exists, always exists in real numbers.
Yes, sir.
All right. If you take, if you see, is it true if the domain R star is replaced by natural numbers? Now I will replace with natural numbers. If I replace with natural numbers, what will happen? Question. What will happen? Now replace R star domain. R star with this domain, है ना? Yeah. Natural numbers to R star. Is that okay?
Yes,
This
sir.
is what he's saying. Is it true if the domain R star is replaced by N? There's a question. Now I replace. Now you tell me whether it is 1 1 and not 2. Question 1 1. Is it 1 1 or not? 1 1 where we are testing 1 1.
Sir, I think it is a 1-1 function.
Yes, whatever elements you take here, different elements.
Yeah, you
take,
will have a
different images.
different image, but it's not onto.
Very good. 1, 1. Yes. How do you prove? Same way. Yes. How do you prove? Like that. F of x1 equal to f of x2. 1 by x1 equal to 1 by x2. And x1 equal to x2. So 1 by x1, 1 by x2, it will be here. And x1, x2 will be here. Okay, different elements if you take, you will get different images. 1, 2, 3,
Yes,
4.
sir.
इसका images so हो जाता 1 by 2, 1 by 3, 1 by 4. Okay, good. So on to. So how do you check on to? Codomain तो R star हो गया. Codomain is R star. The range is something else. Yeah, tell me. On to no. How do you prove? Pre-image तो exist नहीं होता ना.
Yes, sir.
Okay,
Pre-image.
all the images are fractions. Okay.
Yes, sir.
For natural number, there is no pre-image. So 1 ka, so we can write like this. 1, 2, 3. We can write here. So many things will be there. Negative number का pre-image तो नहीं है ना. So 1, 2, 3. Like that. So 1 by 2, 1 by 3, it's a pre-image will be there. 1 by 2 का, 1 का, 1 by 3 का, but 2 का pre-image नहीं है. 3 का pre-image 1 by 3 नहीं है. Like that. Okay, no. Why? Because pre-image is what? Let f of x equal to y. So 1 by x equal to y. X equal to 1 by y. Yes or no? That means what, you know? This is pre-image is x. That is 1 by y. Yes? But
Yes, sir.
number here problem is for y belongs to R star, 1 by y does not belong to n. Yes or no? Yes or no? If you take y from R star, its pre-image is 1 by y. 2 ka pre-image, 1
by
what? 1 by 2. 1 by 2 does not belong
1 by
to
2
n.
does not exist in natural numbers.
No, that's what pre-image is there, not there. 2 ka pre-image 1 by 2. Either natural numbers not there, so it's not on to
Yes, sir. Got it.
like that.
So when we write this, we're supposed to let y belong to natural numbers such that there is at least one pre-image in real numbers.
Yeah.
Yes.
No,
sir.
how do you see when it is no, you need to take one example and show. This is what I wrote here. This is what I wrote. Pre-image is 1 by y. Okay. For y, so I wrote, no, see, for y belongs to R star. Okay. For y belongs to R star, 1 by y does not belong to n. Yes or no? This is what I wrote. For example, you can give example. 2 belongs to R star. Its pre-image what? Pre-image is 1 by 2. That does not belong to n. Like that, you have to give example.
Yes, sir. Got it.
Right. So now this all we check. We need not do that. Injectivity and subjectivity of the following functions. Do we need to do this? You should give example. Is it 1 1 or not?
So do we have to give an example? Is it compulsory?
First of all, we need to recognize whether it is 1 1 or not. Yes. We need to recognize 1 1 or not. So after recognizing only, then we can say.
So because it's natural numbers, it is a 1-1 function.
Oh, good. Immediate
If it
answer.
was real numbers, then it would not be 1-1.
Yes. Once again, can you check? Sure.
Yes, it is a 1-1 function.
Okay, all right. Second first. Okay, 1 1. So when you say it's 1 1, so you need to prove f maps into n, defined as f of x equal to x square. 1 1. So how do you check? Let x1, see, always you write like this with 2 elements in it. है ना? Such that, like that, such that, this is such that f of x1 equal to f of x2. Okay? Images are equal. Is that okay?
Yes, sir.
That implies x1 square. F of x is x square. X means x square. X1 means x1 square equal to x2 square. That implies x1 must be equal to x2. Why? Since generally what you know, x1 is equal to plus or minus x2. This is general. But x1, x2 what? Natural numbers. There is no question of negative number. But minus x2 does not belong to n. This is not there, na? Understand? See, for
Yes,
example, x square equal, let's say 2 square. X equal to what, you know, plus or minus 2. But in this case, x1, x2 are natural numbers. There is no question of minus x2. You got the point? Minus 2 is not there. You got the point?
Yes, sir.
So since I wrote, since x1 comma x2, simply you should write since x1 and x2 are natural numbers. Positive. Therefore x1 equal to x2. Therefore f is 1, 1. This is one way. Or you take another way also. Or another way is what x1 is not equal to x2. So x1 square is not equal to x2 square. Because here since x1, x2 are natural numbers. Positive. Positive, na? So for positive numbers, if you square also, they will not be equal.
Yes, sir.
Like that, okay?
Yes,
So
sir.
f of x1 is also not equal
X1
to
is
f
not
of
equal to
x2.
f of x2.
So therefore, 1 like that is right.
Yes, sir.
Is it on to or not? On to. How do you check on to? Is it on to or not?
Sir, I don't think it's on to.
Yeah, obviously. Codomain is what? Codomain. What is codomain? Codomain is set of natural numbers. And this is codomain.
Yes, sir.
What is range? Perfect squares. Yes or no?
Yes, sir.
अरे codomain तो natural numbers है ना?
Yes, I got it.
Range is what is range? 1, 4, 9 है ना? ये वाला perfect squares. That means what? For
Yes,
perfect squares only there is preimage.
Yes, sir. So it's
Yeah.
not.
Like this. You all 1, 2, 3, 4 है ना? You 1, 2, 3, 4 like this only. But 1 there is image. 2 there is image. But 3 there is image. 2 का preimage what you know? 2 का preimage root 2. Why? For root 2 square is 2. Root 2 square
Yes,
is
sir.
2. So preimage of 2 is root 2. Like that. You
Yes,
understand?
sir.
That root 2 is not there. So otherwise only for perfect square there is preimage. Is that okay?
Yes, sir.
Chalo. Then next one. This is 1, 1 or not. We'll write directly. Directly we'll write. Yes. For this is 1, 1 or not. 1, 1 is fair. Quickly.
So it is 1, 1. Sorry, it is not.
No.
It's not 1, 1.
No.
It's
Why?
not
Because
possible.
minus
Negative
1
numbers
and
are also included.
yeah, minus 1 and plus 1 have the same image.
Yes, sir.
How do you write here? Very simple. No? Simply 1, 1. No. How do you write here? Question is how do you write? Minus 1 and plus 1 have the same image. 1. Or minus 2 and plus 2 have the same image. 4. Different elements have the same image. Simple.
So, sir, we give an example and prove it here, no?
Yes, there is no counter.
We don't have to give
no.
a separate proof as such.
No, not. No.
Yes,
as
got it.
minus 1, comma 1. Okay.
Have the same image.
Have the same image. Different elements have same image. Okay. One case
Yes,
fail,
sir.
one case it's failing. Is fail in one case, then it is not, right? It's enough to show it is fail in one case. Okay, on to, what about on to?
Sir, it isn't onto also.
Not on to. Why? Because perfect squares.
Perfect
Yes, sir.
squares, yes, sir.
Perfect squares only. Codomain is Z, not equal to perfect squares. Here, range is what you know, 0, 1, 2 square, 4 square, like that. 3 square, 4 square, like that. Codomain is not
So,
equal to
for
range.
proving this, if we just write not onto because the domain is not equal to the, sorry, codomain is
Range.
not equal to the range, it's enough.
Yes, enough. Codomain is.
Yes, sir.
Codomain is not equal to range. You should write codomain is Z. But range you should write.
Ranges,
Range
yes,
is
sir.
0, 1, 4, 9, 16. This is enough. Perfect squares. So codomain is not equal to range. It's not on enough, no. Range means what? Only these elements have pre-image. So -1, -2, they don't have pre-image. Like that. Next, what about 3?
Yes, sir.
What about 3?
So this is not onto.
Not onto. Not
I
onto.
don't. It's not this one also.
Okay, 1, what about 1?
It's not 1 or onto.
Not onto also.
Yes, sir.
Same reason. So we discussed
Yes, the same reason.
X square is always positive. Okay, that means
Yes, sir.
positive elements only have three images. All the images are positive. That means only positive elements have three images. Yeah, and then next for fourth, what about fourth? Sorry. What about fourth?
It is 1.
Good, 1. But not
But it isn't. What is the subjective? It isn't onto.
good because same reason.
It's Q. Yes, sir.
Q only.
So again, you'll
Okay.
get 1.
Only perfect
8.
twos. Yes, 1
Yes,
8.
sir.
Only those are the images. That means those images only have 3 images. Okay, same
Yes,
with
sir.
this. Same with this.
Yes, sir. Done.
Yeah, here. Yeah. Third question. Yeah, what is the problem here? There's no problem. Just prove that the greatest integer function we learned already. F of r. Okay, f of r to r given by f of x equal to greatest integer function is neither 1 nor non-2, where this represents greatest integer, which is less than or equal to x. This we learned in 11th grade. Greatest integer function we learned. Yes or no?
Yes, sir.
Yes. So greatest integer function we learned in 11th grade. So same thing we have to see here and do. 1 Is it 1 or not in the question? Different elements should have same image. But f of 2.1, how much? Greatest integral part of 2.1. How much? Yes, integral part of 2.1.
2.
2. Integral part of 2.5.
2.
है ना हो गया ना? So 2.1
Yes, sir.
2.9 same image.
Hmm.
So this is set of real.
Therefore, it isn't 1.
It's not on. It's not on. Not
Yes, sir.
1. As all the 2 point, all those things. That is the reason this graph is like this now. 0 to 1, all 1 only. When it is 1, then it comes here.
Yes, sir.
1.1, 1.2, 1.2 till there, all this is all like this. It's 1 only. So from here to here, all unknown. When it comes to 2, it's not here. 2 is here. That means what? 0.1, 0.2, 0. All will have 0 only. Image is 0 only. Okay.
Yes, sir.
So next, on to or not. One example I give. Different elements have same image. That's enough. On to. On to what? Codomain is what? Tell me what is codomain? Set up that.
So codomain is also so, it's not onto also.
Yeah, I'm not on to. Why?
Because
Codomain is R. Range. What is
codomain
range?
is R, but range is only
Good.
whole
Range is
numbers.
only integers. Integers.
Yeah,
I
yes,
know.
yes, sir, sorry, integers.
Yeah, minus 1 also. Integral part.
Yes,
Oh,
sir.
minus 2.5, you know what? Minus 2 point
Three.
integral part.
Minus
of
3.
Ah, good. Good. Good.
Yes, sir. So you explained it in detail then. So
Nice. You remembered it. Good. If you remembered it, then I explained it. Good. I explained in detail. Okay. Again, show that the modulus function. This also we discussed. F of x could mod x is neither on 1 nor on 2. There mod x is x if x is positive or 0. Okay. If it is 0 and the mod x is negative, it is negative. That's a definition. Yes?
yes,
Tell,
sir.
tell me what. Simple questions are there.
So he only gave it that's not 1, 1 or onto.
There is on 1 or on 2. Yes, yes. Okay. If you prove 1, 1, how do you prove it's not 1? This अपने आप साथ को आना. There are no more students.
Yes, sir.
So simple. Give example. Quick.
Minus 1 is equal to 1.
Good. Very good. Minus 1, comma 1 have same image.
Have the same image. Yes, sir.
Same image. That is 1. Okay, f of minus 1 is mod minus 1. F of 1 is 1.
Also
So
1.
two different elements have the same image. Therefore, not like that if it's like it. Not. 1 to or not? 1 to or not? What is R? What is range?
Range is again set of integers.
No.
No. That is range is set of natural numbers.
No. Mod x है ना f of x range is f of x is mod x है ना mod x is greater than equal to 0 always.
So it's
Range
whole
is-
numbers.
No. So f of x is like this. Mod x है ना mod x is what you know minus x if x is greater than 0. 0. Okay, if x is 0 and minus
X
x.
is 0.
Minus x if x is less than 0. If it is negative,
Yes,
one
sir.
more negative to make it positive. So positive real
Yes,
number.
sir.
So that's what I wrote. Greater than 0, positive real number.
Mm.
Positive real number.
Yes, sir.
So understand it is positive real number. X is a real number. Mod x is positive real number. That's it. Okay.
Yes, sir. Got it.
So next, signum function. You remember what is signum function? Show that signum function like this. If x is positive,
Yeah, I
it's
don't
positive.
remember signum function.
Yes,
like
if
okay.
if x is positive, its value is 1. If x is 0, it is 0. If x is negative, it is 1.
Yes, sir. Got
Yeah,
it.
like this. We write f of x equal to x. F of x equal to here mod x by x. And a mod x by x. If x is greater than 0, what will happen if x is greater than 0? This is x by x na 1. If x is 0, simply it is 0. We need not write this one. Okay. If x is less than 0, this is minus x by x. That is minus. Like that. We write mod x by x. Graph will be like this. If 0, 0. If x is positive, then it will be like this. If x is negative, it will be like this. For negative number, this is a graph. For positive number, this is a graph. Like this. Obviously,
Yes, sir.
these all numbers only
To be
images
one
this.
only.
One only.
Mm.
All these different elements. 1 ka image, 1, 2 ka image, 1, 3 ka
One.
image, 4 ka image. X is greater than 0, image only 1. So all different elements have same image. Therefore, not 1. Onto, not onto, because only images are 1, 0, minus 1. Minus 1.
Yes, sir.
Now, these are the only
Codomain is
images.
set of all real numbers, so it's not equal to.
Ranges is, yeah. Let A is this, B is this, F is this. Be a function from here, show that, okay, that you can do.
So this is direct only. You can just show it by mapping.